Hey, good morning. I'm here to talk about JavaScript project architecture, mainly JavaScript services from Sitecore and the Helix principles. For those who don't know me yet, I am Jean-François Lheureux from Canada. I'm working at Coveo as a technical evangelist on the Coveo for Sitecore project, and I'm really into front-end development and Sitecore, of course. I'm also a Sitecore MVP for the last 2 years. And this year I won the Sitecore Hackathon in the JavaScript services category. Traditionally, the front-end part of a web application was done in the backend code as MVC. So MVC controllers, views, and models. And from these days, we are seeing a shift in the technologies used to build the user interface of the web application. It's now shifting to JavaScript frameworks, and when we use CMS, it's shifting into a headless way of communicating with the CMS. So really, we are seeing a shift in the code complexity from the backend to the front end now. And it's not because it's a front-end project that it cannot go wrong as a code architecture. A project that starts really small can quickly become a mess of dependent code and dependent files, hard to maintain and also hard to create new classes and advance the project because of that. So Sitecore is very aware that their platform is really flexible, and because of that, it tends to create much more complex solutions than other CMS maybe. So that's why 2 years ago, they created the Helix principles and conventions. Those are really to help you build projects that will maintain better over time. So in a nutshell, it's a set of guidelines that when you follow them, it ensures a clean code architecture. It ensures also that you will have low technical depth and will be able to add features to test and to maintain the solution quicker than if you don't follow the principles, basically. The main principle of Helix is the layers, the 3 layers: foundation, feature, and project. The foundation layer contains the most stable code, the code that changes less often. You can see it as the dependency injection container, the indexing foundation, the authentication, for example. So code that when set, it doesn't change very much. The feature layer contains most of the features that the business user sees in the website. So for example, the search features, the news, the articles, the user login, so accounts and rows inside the system. So those are subject to change often when you develop the project. And the project layer contains the different channel outputs of the implementation you are doing. So it can contain one or more sites that will be the end results in a multi-site scenario. The second thing that's very important in Helix is the flow of dependencies. The project can depend on features and foundation, and a feature can only depend on foundation. You cannot go in the reverse order. So you have a one-way dependency flow. Inside those layers, Helix tells you to split the code and the assets in different modules. So the foundation modules are really what I told before, like the dependency injection, the serialization, the indexing. In the project layer, the one at the top, then you will have the various channel outputs of the implementation. That can be sites, but that can also be email experience manager projects or print experience manager projects if you'd like. In a multi-site and multi-tenant environment, you will have one module per tenant, and one module per site that you will have in the implementation. You can also have common modules for sharing code among all the tenants or among all the sites as well. Then in the middle layer, the feature layer, you will have all the individual features of the different channels, mostly the website. So accounts, search, news, etc. And one thing that is important also is the dependency between the modules. So at the project and foundation layer, the modules can reference each other. So the site module references its tenant module that reference a common tenant module, for example. Same thing at the foundation layer. However, Helix specifically tells you to avoid having cross references at the feature level, in the feature layer. So a module in the feature like accounts cannot refer to the search module, for example. That's something very important. And all of Helix is mostly based on the common closure principle. So it states that everything that changes together is packaged together. So not only code is present in the different modules, there's also all the configuration for Sitecore for that module, all the Sitecore items that are serialized, and all the unit tests for that module. Those are all packaged together in the file system. That's another important thing in Helix. Now let's talk about Sitecore JavaScript services, JSS for its short name. JSS is the official Sitecore way to connect to the Sitecore Experience platform and use the features in a headless way. It allows the front-end developers to work with Sitecore with little to no knowledge of the platform itself. So they can build the user interface separately from the Sitecore items and Sitecore complexities. It allows those front-end developers to use all the features of Sitecore, including personalization. They can start very quickly in disconnected mode, where they will fake the Sitecore layout data in JSON or YAML files. And later on, when the Sitecore project takes form and the content starts to be added in the content tree, they can switch to connected mode or Sitecore first mode, where the data will be pulled from Sitecore through a new service called the layout service. JavaScript services support the main JS frameworks out there, so Angular, Vue.js, React, and React Native. My example in this presentation will be all in React. To create an application for one of those frameworks with JSS, you need an application template. The application template contains all the boilerplate code and the configuration to get up and running with a project on one of those frameworks. The Sitecore JSS team has published one app template for each of those frameworks, and their app templates don't contain only the boilerplate code, but it also contains a sample website to get you started with JSS. The sample website is just a style guide for all the JSS field types inside Sitecore. To create one of those projects, you need to install first the JavaScript services command line interface called JSS, and you can call JSS create with the name of the application you want to create and the name of the application template. So for example, to create one with the React template, you call JSS create the name you want and React. So Sim React is the name of my application I want to create, and React is the name of the template from the JSS team. When I run that in a command line, first it gets the application template from the Sitecore JSS GitHub repository, where they have all the code for all the templates. Then it extracts the template on your file system in the folder of the name of your application. Then it installs the package using Yarn. That's the part that takes the longest time. It can take a few minutes depending on the speed of your internet connection. So that's why I avoid doing it live here because of the spotty connection. So after installing all the packages, it runs some scripts to change variable names and file names inside your new application. And then it shows a nice ASCII art of the Sitecore JSS logo and tells you that your application is ready to be used. So let's inspect the code of that application. Here I have this exact application I have created, SimReact, with all its code. The first thing I will do will be to start the application, start the development server. So it's using JSS start. This will compile the development server and start a browser to the page hosted in that development server. When the page will load in my browser, then the first request to the server will compile all the website, and when the site will be compiled, it will be served to the browser. So I will just wait for my browser to open. It will open on the localhost URL, localhost with the port 3000 here. So while the application is compiling here, the development server is started. I will explain you the source code of the sample JSS application in React. So first, the entry point is index.js. It uses a few other files as imports, but the main thing is it renders an app root. So app root is also at the root of the source folder. This one uses the root handler for the routing. So root handler is also one defined here, and root handler defines to use, where it is, it uses the layout here. So return a layout, and layout is the real layout of the application, including the navigation, the headers, etc. So this is kind of like a layout inside traditional Sitecore MVC application. So all of those files refer to the website itself. After that, we have some folders with assets, so the logo to use on the website and some CSS. We have components where we have a content block that is reused in many pages of the site, some GraphQL components as well, and all the style guide components for this application. One component per Sitecore field type that can be used in JavaScript application. So this is clearly some of the features in the Helix terminology. We also have a lib folder with some GraphQL and Sitecore context libraries. And we have lastly a temp folder with generated files from some scripts that I will explain later. So now if I check my console, the development server compiled the application successfully. We can see it at localhost 3000. If I go back to the browser, this is the sample website of Sitecore JSS. There's a documentation link to the external documentation, and there's the style guide section here. It routes to /style guide, and it contains one component per field type inside Sitecore, so multi-line text, rich text, images, etc. So this is the application. I want to explain you how to convert to an Helix structure. Before moving any file to the Helix structure, I want to see my changes live, and since I don't have two screens, I will open the style guide page inside Visual Studio Code directly. So I will open a URL and type that. And I will just reorganize the windows. So I have a small browser here that displays the same website, just a little bit smaller. So as I modify the files, I will see live the changes in my browser. So the first thing, the low-hanging fruit in my sense, is the components folder here. It seems to contain all the feature layer modules and components I want. So what I will do is first create a folder called feature and style guide, like style guide without typos. So it creates features and style guide under. And I will slowly move files from my style guide that I did a typo. Style guide like this. So first I will move style guide specimen here, which is the component in React that is the base component for all the other style guide components. So if I move this one here, Visual Studio Code asks me if I am sure I want to move it. If I do move the component, then at the bottom we see that the application failed to compile. That's normal because I just moved a file that was referred by other files in the application, and as I change the files, it recompiles. So now there's invalid import statements in many files. Visual Studio Code is intelligent enough to ask me if I want to automatically update the imports for the moved files. So that's very smart. If I click yes, then it opens and updates all the files that we are referring to that file. So for example, here I have import style guide specimen, and now it's imported from the feature style guide folder. So I want to save all of those files. There are 17 of them, and I will close all of them, close to the right. So now the application recompiled after saving all the files, and my style guide continues to work as expected as before. If I check the console, it shows that it failed to compile first, and then it compiled successfully after the next save operation I did. So I can continue to move the components from the components folder to the feature style guide folder. The first one I moved is Sitecore context, and my application continues to work, so this one wasn't imported anywhere else. If I move also the style guide section, then it seems to continue to work. However, I have a different output here. It seems to have broken the application. I switched to my browser to see a better view of it. So it seems that the style guide section component have broke the interface, and it says that the component is missing a React implementation, and see the developer console for more information. If I open the developer console, I see that the placeholder contains an unknown component, style guide section. It asks me to ensure that the component exists and it's registered in the component factory.js file. So that's a good tip. Inside the Sitecore JSS application, I mentioned there were some automatically generated files. Component factory is one of them. It's a file that's generated by the generate component factory.js script, and it imports all the components of the application and then registers them in a map to the component factory. The component factory is a layer in a JSS application that maps the Sitecore rendering information to the components inside your application, here React components. It needs to have a map of the names of the renderings inside Sitecore versus the names of the classes inside your application to initialize the renderings. And as I moved the features, the different components from the components folder to the style guide folder, then the import file here started to miss some of the components. So I don't have style guide section and Sitecore context anymore here. That's because this script here is only reading from the source/components folder of the application. It doesn't look in our feature, foundation, and project folders from our Helix structure. So that's the problem. To fix the problem, I would need to update the script, this script here. I won't do it live here, it would take too much time. I have already created that script in another application for you. So what I will do is close my terminal to stop the development server and close that application, switch to the version 2. Version 2, I will first JSS start the application, and while it is starting, I will explain you the new structure. So now I have the feature with style guide again, but now I moved all the Sitecore components that are also on the Sitecore items in a components folder as before, and everything else that's not Sitecore components, I put it at the root of the feature folder. So style guide specimen is the base class, but it's not a Sitecore component. Same thing for GraphQL, 3 components. Errors, I have the not found component, and content block, I have one of them here. In the foundation, I created the context for the Sitecore context factory, GraphQL module for the GraphQL libraries, and translation for the internationalization library. In project, I have a single project output, the website I'm creating. I named it the same as my JSS application, so Sim React Helix layers. And it contains the assets and everything related to the application. I kept the index.js at the root of the source folder because it's the entry point of the Webpack compiling and everything. The script itself to generate the component factory has been modified to read from the source folder, and I read only the foundation feature projects folders and the components folder inside those. So now that I have a working solution, I can prove it works by navigating to the style guide in my localhost application. Now that it's working, it doesn't mean that I can go ahead and code everything I want. I can break the dependency flow of a JSS application. I could, if I want, refer from a foundation to a feature. So if I do an import here, import not found, which is one of my feature, from the feature errors and not found. If I do that, it still allows me to import in different folders where I'm not supposed to. And when I do this, the application still continues to work. There's no problem in there for the application itself. So it would be good if we could validate that the imports here to avoid importing from the layers that we are not supposed to import from. And same thing for the features themselves. Avoid importing from one feature to another one. That can be done using a linter. A linter is a software that statically analyzes your code and will flag some things that are not correct given the rules you set on the linter. We are lucky because the React applications created by JSS are using ESLint by default, and the ESLint is provided by Create React App from Facebook. So the JSS application don't have to depend on ESLint. It's automatic because on how the application is created. However, even if there's an ESLint RC file at the root of the application, this file is not used by either Sitecore JSS or by Create React App. So this file is useless at the moment. The configuration for ESLint that is used when you compile the solution is the default configuration from Create React App. That's how it works. And there are two ways to change that and use our local ESLint RC file. The first one is to eject the application. Ejecting means that all the magic and the complexity handled by Create React App for our application will now be transferred inside our application, and it will become very complex. So that's not something you want. The second way is to only rewire some parts of Create React App. So we can want to rewire only the ESLint part to use our local ESLint configuration instead of the default one. So that's what I did, and I will show you how it works. Let me close this one. I don't want to save that. And switch to the last project here. I will JSS start it just to show you. And while I'm starting it, let's start with the package.json. So in order to lint the files myself using my ESLint RC file, I first added a dependency, a dev dependency on ESLint and two of its plugins. Those two plugins are used in the ESLint JSON file here, import and react. Now that I have ESLint, it was really important that the ESLint version was 4.19.1 because Create React App is using this exact version. So a thing to note if you have to do the same thing. Now that I had ESLint in my project, I added a script inside the package.json, allowing me to call ESLint on all the JavaScript files. So now what I can do, I can open a terminal and run yarn lint or npm run lint, and it uses ESLint and my local configuration to test the application. It finds one problem, a missing file, index.html in the build folder. That's normal. It's a file that will be created when we will run in connected mode instead of disconnected mode. So we can ignore that error for the moment. Now that I'm able to manually lint, I need to be able to automatically lint using the same configuration by rewiring the linting phase. So the rewiring is done by adding two React dependencies, React App Rewired and React App Rewire ESLint. Those require a config overrides.js file that imports the ESLint rewire module and just calls rewire ESLint with the configuration. So now instead of using the default ESLint config, it will use my own configuration. So it means that when I modify the files, then I should have automatic validation. The configuration in ESLint.js file was untouched, except from line 42 to 56. That's the part that I added to validate the Helix layers dependencies. So I want to avoid imports from restricted paths and give errors if I found some. I have two zones for the moment. I restrict foundation code to access the feature code, and I also restrict the foundation to access the project code. So that's only one part of the flow of dependencies that I validate here, because at the feature level, it's much more complex. Features cannot access projects, but they also cannot access each other. So I will cover that separately. So let's test that that configuration here. If I go to my sources, foundation, context, and I do the same import as before, import not found from dot 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 feature errors not found. Here it's highlighted, it's underlined, and I see that the second validation, unexpected path imported in restricted zone, is my new validation. So it validates as I type because I have the ESLint extension installed in Visual Studio Code. It also validates as I save. So when I save, the project is recompiled, and I will see an error directly inside the console of JSS start with the unexpected path in the restricted zone again. And if I switch to the browser, I have the exact same error in my browser because I'm not respecting the dependency flow of Helix. For the features themselves, it was more complex. So I created a script called generate features ESLint config. This one watches the folders inside the feature folder. If I go to the feature folder, it watches the folders here and generates a second ESLint rc.json file, because ESLint can work with multiple files like git ignore, and it says that this file is generated, and this one first contains the limitation for features to access the project code, and also one zone per folder. So content block cannot access errors, GraphQL, and style guide. Same thing for errors, GraphQL, and style guide. If I add a new folder here called sim, then the file is updated automatically. So I now have feature sim that cannot access the 4 other folders, and all the other folders cannot access feature sim. It also works if you do rename. So Symposium, it updates the file automatically, and same thing if I delete one folder, it updates the file. So that's pretty nice. If I go in one of the feature like content block, and I decide to import from another feature, import not found from errors not found, like this, then I have the same validation, the restricted zone, and if I save the file, I will have the same error, unexpected path in restricted zone here. So it works very well for this, and same thing here, I have this in my content block index.js. So that's all I have for the code. Now for the code location. A JSS project, like the one I just mentioned, was created separately from the backend project with the other Sitecore code. So you have a choice to make here when you are Elixifying your JSS project. You can have the code in a separate repository than the Sitecore code. That works. But if you do so, please ensure you use the same uh, module names inside the backend code and the front-end code. So my friend Vitaly Tilik wrote a good article about Helix and Sitecore GSS recently, and this quote from him is what I think is really important. Like, keep the names the same in the backend and the front-end code, because it will ease the communication between front-end developers and backend developers mostly. You can also have the code in a single repository, but in separate folders. So in a Sitecore Helix solution, normally the code is in the source folder. You can have the JSS code in a front-end source folder or something like that. Or you can mix the JSS features code directly inside the folders of your Helix modules for the backend. So if you have an account module in the feature layer in the backend, you have already a code, test, and serialization folders. You can then create a front-end folder besides them and create code and test inside that front-end folder for the GSS code. But now opening the various GSS code in your text editor like VS Code can become quite complex because it is split in multiple folders in the file system. Visual Studio Code has a solution for that. It's called Workplaces. So it allows you to open many folders in the same Visual Studio Code solution. So that can be tested to see if it works. So all I have presented today is now available inside the GSS app templates repository in GitHub in my name. And it allows you to create new GSS applications from this template. All you have to do is when you type JSS create in the terminal, you specify the React Helix template and you specify -- repository with this repository name at the end. And instead of fetching the app template from the official JSS repository, it fetches the app template from my own repository. Also, have a look at my blog. I will publish a lot of articles related to Helix and JavaScript services in the next days. So that will be the resume of this presentation. The next steps for me is to look at unit testing. So currently the sample application doesn't have any unit test, but if you are a good developer, you will test your features and modules. So unit tests should be inside the different module folders because of the common closure principle. So I would likely have to create a code folder inside each module and a unit test folder as well. I want also to take care of the other folders in the solution. There are a data folder and a Sitecore folder that contains the fake data as well as the Sitecore definitions for the templates and the items to create in the content tree. Those should be also inside the different modules as data and Sitecore folders maybe, or data and serialization or things like that. And the Sitecore items that are created in the Sitecore content tree when you deploy the application in Sitecore are all created in the same folders. So for the templates, for example, they are in /Sitecore/templates/ the name of your project. And it doesn't split the templates by Helix layer and Helix module. So that would be something to do, but it requires new code inside the front-end and back-end application to split the templates at the right location.